Hi everyone, this is Kalyan Kumar and welcome once again to Chemistry Universe. And this is a special series on quantum mechanics. And in this particular series, I'm going to talk about what is a wave equation, what is the Schrodinger wave equation, both the time independent and the time dependent. Then I'm going to talk about what is the interpretation of the Schrodinger wave equation and what does probability density mean. And then we'll talk about the probability distribution of each of the orbitals that we get. And we are going to look at variety of things. And I'm assuming that the student or the person who's watching this particular video is a student of 11th grade who's just probably started preparing for an entrance exam. And therefore, I'm going to start with the very basics. So, we are going to talk about what is known as the Schrodinger wave equation. But to understand the Schrodinger wave equation, one must understand what a wave equation actually is. What does a wave equation actually mean? So, let's start and figure out what is a wave equation. Now, here, as you can see, we have to first of all understand what is a wave equation. So let's look at a particular wave. Now have a look at this wave carefully. Now just imagine that this is a wave, let's say probably happening in an ocean. It's a water wave and you're standing somewhere here. This is the some platform in an ocean, some oil rig or something, and this is the shore where one of your friends is standing and the water waves are going up and down like this. Now obviously water waves are not going to be this uniform, but we are first of all going to take a very simple case of a uniform wave so that we'll be able to figure out what a wave equation is. Now having said this, let's understand what is it that we want to build today. Now, as you can see, this is a graph which has a vertical height on the y scale and the horizontal position on the x scale. So, what do you want to do in any graph? Now, in any graph, you would want to find an equation of y in terms of x. That's the basic purpose, right? That's what you want a wave equation for. So, you want a wave or any graph to find an equation between y and x. So let's assume that as this wave is traveling from left to right, somebody just took a snapshot, just took an image and gave us this image and told us, okay, build an equation of this wave. So y with respect to x, what would be that equation? So this is an image of the wave at a given point in time. And what is the wave equation supposed to give us? The wave equation is supposed to give us the value of y when we plug in a particular value of x. So y should be some function of x. Now here you will notice that this is actually a sine wave, as you can see. Why do I call it a sine wave? Well, if this were angle on the horizontal axis, then this would be 0 and sine 0 we know is 0. Here could be sine 90 or sine pi by 2, which is 1. But of course, the y value when this is pi by 2 is not 1, it is actually 3. So we definitely know that when we want to build an equation, we need to get the amplitude here, which is in this case 3, and multiply that with the sine equation, the sine function here. So when this value reaches pi by 2, it has to reach the maximum value. So I want some particular value inside this bracket, which will make sure that the sine of that value becomes 1. And since the amplitude is 3, y would become equal to 3. Now obviously the one that is inside should be having some x in it. So how do we do that? So what we do is, let's look at this wave. Now, as you look at this wave, you'll notice it starts from 0 and the wave completes here at 4 meters. Then again it completes at 8 meters. So it completes one full wave at 4 meters, which means 4 meters is the wavelength. So if this were an angle, this would be 0, this would be pi by 2, this would be pi, this would be 3 pi by 2, and this would be 2 pi. So the wave resets itself after 2 pi. After 2 pi, it again begins and ends. Again, it begins and ends. So I sure want to get some angle inside. I cannot simply write x here because x is in meters. X is the horizontal distance of the wave. So I need to get here an angle, and this angle should contain the x value. So how do I do that? Well, this is the logic that I use. If the wave moves a distance lambda on the y-axis, in this case it is 4, then it would have moved by an angle 2 pi. Because remember, if this is an angle, this place is 2 pi. So when it moves a distance lambda on the horizontal axis, the angle it has moved is 2 pi. So if it moves by some distance x, what would be the angle it will traverse? That would be 2 pi x over lambda. This means that for a given value of x, the angle for the sine wave would be 2 pi x by lambda. So this means I should get y equal to a sine 2x 2 pi x over lambda. So this is my wave equation for this particular image of the wave. I hope you can get it. Now, to make sure that we are getting the right equation, let's take any particular value. Let's say I take the value of the wave as 1. The x value is 1. Let me find the y value. So y would be, remember, I want to find the value of y at 1 meters. So A is 3 is the amplitude, sine 2 pi, and I need to get x by lambda. Now x I want is 1 meters, and lambda, as you can see, is 4 meters. So what do I get? 3 sine pi by 2. And what is sine pi by 2? Sine pi by 2 is 1. What is 1 into 3? 3. And you can see that when the x is 1, the displacement of the y-axis is actually 3 meters. You can check this for any other point. Let's say, for example, let's take 3. So y would be 3 sine 2 pi x over lambda. And as you can see, this is 3 pi by 2. So y is 3 sine 3 pi by 2, and 3 pi by 2, if you remember, is -1. So it is -3, and that's what we get. So we are okay with this, and we are able to get the equation for this particular graph. But remember, somebody had taken a picture of this graph and given it to me, and I made an equation with respect to this graph. So let's check whether another sine wave of a different lambda would also work with this equation. Because I have kept the lambda as a variable. I have not kept the lambda as 4. It's only when I want to get the value of x for this particular wave that I use the value for. Will it work for this wave, whose wavelength, as you can see, is 7 meters? Let's check. Let's find the reverse thing. Now, I want to know, and I've tried to keep the amplitude same. So this amplitude is still 3. So I want to know at what position of x is the amplitude maximum, 3. So y I know is already 3, and a is also 3 sine 2 pi. And remember, right now I want to find the value of x for which the y value is 3. So I'll keep x as the variable. Lambda, as you can see, is 7 meters. And here you will get 3 gets cancelled. So this entire thing can be taken as pi by 2. So if 2 pi x over 7 is pi by 2, pi gets cut. And you will get x, you can get the value of x as 7 by 4, which if you calculate is 1.75. That means this is the value of x, which is 1.75, where the y value is maximum, that is 3. So this means this equation works for any kind of a sine wave. Now, the next question that we need to answer is, what if the wave is not a sine wave? So let's remove this and let's shift the graph here. What if it were a graph like this? Well, as you can see, this is a cosine wave. Because if these were angles, then at 0 it is maximum. At pi by 2 it is 0. At pi it is amplitude is negative. The value is -1. Again, you get this and it goes on. And the wavelength again is the same because I moved the same wave. So what would happen is I will change this equation from the sine wave to a cosine wave and be done with it. You want to check? Let's check. Let's check what happens at x equal to 2. So y equals a, which is 3 again. Sine 2 pi, it's cos now. Cos 2 pi x by lambda. And lambda is 4. So this is 1 by 2. And this is cos of pi. And what is the cos of pi? It is -1. So I get this into -1, that is -3. And I get the value of -3. So this is a cosine wave. So that's perfectly fine. All right. Now the next thing that we're going to do is move it back to the sine wave. Okay. So when we move it back to the sine wave, let's understand what are we trying to find out. Now, we already saw y is a sine 2 pi x by lambda for this particular wave. But the problem is, what would happen if it were neither a sine wave nor a cosine wave? Suppose, let me make this wave move to the right. Now, if you notice here, this is neither a sine wave nor a cosine wave. Now, you will say, okay, I'll just put a negative value before the sign and maybe get the value of this graph. Well, there's a better way of dealing with this. So, what if the wave is neither a sine or a cosine wave? So, what we do is we change the angle in such a way, change the angle inside in such a way that I'll automatically get this particular value for this particular wave. Now, how is that even possible? Well, it's like this. What we do is we add or subtract something in the angle which will help us get the equation for this wave. That is called a phase shift. So, if we are using a sine wave function to get this particular value of the wave, then we need to add or subtract a phase shift to make it work for all types of waves. So, it doesn't matter which wave you have, as long as the wave is given to you, you can find out what the phase shift is, and you can add or subtract a phase shift into the angle part of the sine equation. You can even use a cosine equation for that matter. We are right now using sine. So, if you're using a sine wave function, then you add or subtract a cosine, a particular phase shift, which will help you get the equation for the new wave. So, how are you going to do that? Well, we are going to add or subtract a phase shift and let the phase shift be phi. Now, if you remember, this graph, this point was initially here, right? And it has moved 1 meter to the right. So, has it not moved by a quarter value? Because the wavelength is 4. So, if the wavelength is 4, had it moved 4 meters, it would have moved by an angle of 2 pi. If it moves only by 1 meter, isn't it quarter of 2 pi? which is pi by 2. So all I have to do is add or subtract the value pi by 2 into this equation to get the equation for the new wave. Now the question you will ask yourself is, should I add or should I subtract? Well, the answer is simple. If the graph is moving to the right, you will subtract. And if you're moving it to the left, you will add. Now, this may seem counterintuitive to you because we believe if it is going in the positive x direction, you need to add. If it is moving the negative x direction, you need to subtract. But actually, it is the other way around. And let's understand why is that. So suppose you have a graph like this, okay? And you have a graph of a straight line that is passing through the origin. And let's say this angle is 45 degrees. Now, what is the equation of this line? You can clearly see since the slope is 1 and there is no intercept, this equation of the equation of this line is y is equal to x. Now let me move the graph to the right. So if I do this, and let's say this value of x is 2, what will be the equation of this line? As you can clearly notice, the value of x is 2 when the value of y is 0. So when y is 0, x is 2. So what should be the equation that will get this? The only way you can get this is y equal to x minus 2. Because if y is x minus 2, y will be 0 when x is 2. Can you notice that as the graph moved to the right, I'm subtracting something from x? So remember, when there is a phase shift for a graph moving to the right, you will have to subtract a value. So, and we know right now the value is pi by 2. So I say it is a sine 2 pi x over lambda minus pi by 2. Now this particular value of y equal to a sine 2 pi x by lambda plus minus phi is called a time independent wave equation. Now let's get back the sine wave that we used in the beginning. Now, but again you will notice that all these equations are meant for waves whose picture has been taken at a given point in time because they were for particular waves. The problem, however, is these waves are moving continuously from left to right. So what do we do? So these equations are for waves at a given point in time, but these waves are continuously moving from left to right. So we need to ensure that the phase shift is not a constant. In fact, it should be something which should be a function of time. So we must get an equation that is not only a function of the distance, but also the function of time, which means we should get y is equal to a function of x and t. Now let's assume that the graph moved to the right and by 1 meter. So here we have the graph moving to the right, the blue wave, and we know that the phase shift cannot be a constant. It should be a function of time because we need to get the phase shift as different values at different points of time. So now the question is, what should it be based on? So we know y is a sine 2 pi x over lambda subtracted, we need a phase shift. Now the phase shift should adjust itself in such a way that at time 0 it should be for the red wave, and after it has moved, let's say by 1 meter, it should give us the blue wave. At different points of time it should give us different waves. So how do we do that? Well, it's pretty simple. If you look at the graph, you'll notice that during the time period, if the time period of the wave is t, where time period is defined as the time for making the wave move by one particular wavelength, 1 lambda, you'll notice that when it moves through a time interval of t, which is the time period of the wave, then the angle traversed is 2 pi. Because from here to here, it is 2 pi, as you can see. So from point this and point this, it is 2 pi. So for one time period, it will move by an angle of 2 pi. If it moves through t time period or t time, then the angle traversed would be 2 pi t over t. Which means if from the red graph, if red graph were the point of time in the beginning, when t is 0, then definitely it will be the red graph, right? But after a certain amount of time, this red graph must have moved by a certain distance at a certain interval of time. So if it moves through t time, it must have gone through an angle of 2 pi t by t, which means what I need to subtract here is 2 pi small t by big T, which means the phase shift should be a function of time period. And what should be that? It should be a sine 2 pi x over lambda minus 2 pi t over t. Now let's check if you want to know this. Let's say I want to know what is the y value at 3. So the y value would be a is 3 sine 2 pi, and I want to know the x value, the value of y when x is 3. Lambda, as we know, is 4 minus. Now, how much is the phase shift now? The blue wave has moved by an angle of pi by 2. Or you can say it has moved through a time period that is 1/4 of the time period. Because see, it has moved by a distance of 1 meter. If it were to travel 4 meters, it will travel in t seconds, let's say. So if it moves only by 1 meter, so it has moved by 1/4 of the time period. So it will be 2 pi t by 4 by t. T gets cut. This becomes pi by 2. This becomes 3 pi by 2. This is pi by 2. And if you subtract this, you get pi. And what is the value of sine pi? It is 0. So the sine value is 0, and therefore y equals 0, and that is exactly what you get. And that is the end of this particular video. And this is called the time dependent wave equation, because now it's a function of time. And that completes what a basic wave equation is. So that's it for this particular video. I hope you understood what a basic wave equation is. A wave equation uses x and t if it is a time dependent equation, or if you're given one particular picture of the wave, you can use the phase shift as a constant and get the value of y for a given value of x. So that's the basic purpose of a wave. This is a very simplistic wave traveling in one direction, in the x direction. We are not assuming it to be a very complicated thing. So for a simple wave, this is how we get a wave equation. In the next one, we'll figure out what is the Schrodinger wave equation, both time independent and dependent wave equations. With that, we come to the end of this video. I hope you understood what was being taught here. If you have any questions, any queries, please drop them in the comment section below. With that, this is Kalyan Kumar saying goodbye. Have a nice day. Wonderful. And thank you for watching this.